So it would focus. Okay, I'm ready. So today we're going to talk about how to factor numbers down to prime. And the terms that we need to know the meaning of are prime, P-R-I-M-E, factor, F-A-C-T-O-R, and composite, C-O-M-P-O-S-I-T-E. Okay. A prime number is a number that is only divisible by one and itself. So these are prime numbers. Prime numbers. Prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and etc. And I can see that didn't come out dark, so I'll write over it. We have 2, 3, 5, 7, 11, 13, 17, 19, and 23. And again, those are prime numbers, numbers that are only divisible by one and themselves. Now, another type of numbers that we'll talk about are composites. C-O-M-P-O-S-I-T-E. Composite numbers are numbers that are composed of other factors. Factors are numbers that can multiply together to give you another number. If a number is composite, it has 2 or more factors. So if I give you the number 12, I'll show you how to make a factor tree. The first question you ask yourself is it prime? Because if it is one of the prime numbers that is only divisible by one in itself, then you can't factor it. But if it's not prime, is it prime? No. So you find 2 factors. The factors for 12, give me any 2 numbers that you know that multiply to 12.
6.
6 and what else?
4.
6 times 4 would be 24, but 6 times what is 12? Yeah, 2. So 6 times 2 is 12. So those are factors of 12. But the way we're going to make our factor tree is that as soon as we get a prime number, we're going to circle it so we know we're finished with it. But 6 is not prime because it is composite, because it is composed of the factors 3 times 2. 3 is prime and 2 is prime. Once you get all prime numbers, you have factored the number down to prime. So we started with the number 12 and we factored it down to prime. We got 3 times 2 times 2. Now, sometimes you may be asked, write your answer using exponents. So you have 2 2s, so you say that's 2 squared, 2 to the second times 3. Every time you multiply out the answer, it must always give you the given. So 2 squared is 4 times 3 is 12. Now I want to show you that it doesn't matter that your factor tree doesn't look like somebody else's because there's different ways to factor. Let's take the same number 12. And this time, instead of thinking about 6 times 2, let's think about 4 times 3. Because 12 is composed of the factors 4 times 3. Since 3 is prime, we'll circle it because we don't want to do anything else or can't do anything else with it. And 4 is composed of 2 times 2. So now we factor the 2's. If we were told to write it using exponents, we would write 2 squared times 3, which is exactly the same answer as when we did it the other way. So what I'm saying to you is if you decide that factor it out one way and somebody else does another way, it's still correct, because it's going to lead you back to the given. Okay, now I'm going to tell you a nice, well-known secret. Any number that ends with a 0 is composed of 10 times the number without the 0. So let's say, for example, I give you the number 120. Because it ends in 0, it's 12 times 10. Okay, so we can factor that as 12 times 10. You see? 12 times 10. And now 12 and 10 are both composite because they are composed of other factors. So 12 is 4 times 3. We notice that the 3 is prime, so we circle it. The 4 is not. You say, is it prime? If the answer is no, you keep factoring it. If the answer is yes, you circle it. So 4 is composed of 2 times 2. So we circle. And we still have this 10 up here. 10 is composed of 5 times 2. And now both 5 and 2 are prime. And now all of our endpoints are prime. Once all of the ends of your factor tree are prime numbers, then you have your answer. If you want to write this using exponents, you have 1, 2, 3 2s. So that's 2 to the third times 3 times 5. So we have 2 to the third times 3 times 5. Now to prove that it multiplies out, 8 times 3 is 24 times 5 would be 120. And yes, it does. You see? Let's do one more. Let's say I give you 2,500. That's a pretty big number. But the good news is because it ends in zeros, it's 10 times the number without the 0, 10 times the number without the 0 again, and 25 times that. But the 2 zeros, 10 times 10 is 100, tells you that it's 25 times 100. Okay, so I will factor it first as 25 times 100. I knew the 100 because the 2 zeros. Now I can factor the 25 as 5 times 5. And then what can I factor the 100 as?
50.
Okay, she wants to do 50 times 2. Yeah, you could do that. Or you could have done 10 times 10. It'll still get you the same answer. Let's circle the 2, and what can we do with the 50? If you have 50,
5.
what?
5 10.
5 times 10, good. And now the 5 is prime, I circle it. What can I do with the 10?
5.
5 times 2, very good. 5 times 2, I circle the 5, I circle the 2. And now on the end of my factor tree, I have all prime numbers. I have 1, 2, 3, 4 for the 5. So that would be 5 to the power of 4 times 2,
2.
good, to the power of 2. And if you multiply that out, you'll see, oops, that it will lead you right back here to the 2,500. So you see, factoring is real easy. This is the basics. But if you can do this, it will make it possible later for you to factor trinomials, binomials, polynomials, and all the more higher up algebra type of factors. Are there any questions? Does this make sense? Okay, let's try it out I'll give you some problems to do, and let's see, can you do them? Thank you.